Hello, my name is Larry Chi, and today I will be doing a Think Aloud and Close Reading of Chemistry by John E. McMurray and Robert C. Fay. And the section we will be covering is 2.5. Now, before we begin reading, let's take a look at the heading. Atomic numbers. So this section will have to do with atoms and numbers. So thinking back to the periodic table, I know I remember it's a table full of different elements. It's one of the first things we cover in chemistry, and that there are numbers all over it. So maybe this section will tell me more about those numbers. Also, I notice a diagram at the bottom of the page with little red circles, numbers, positive and negative signs, and more numbers floating around the little red circles. This diagram must be illustrating the point of this section. Okay, let's begin the reading. Thus far, we've described atoms only in general terms and have not yet answered the most important question. What is it that makes one atom different from another? How, for example, does an atom of gold differ from an atom of carbon? So these questions are asking us about what makes atoms different. I'm not too sure what makes them different, but maybe if I keep reading, the text will tell me. Based on the heading of the section, I think the difference has something to do with the atomic number. So let's read on. The answer turns out to be quite simple. Oh, good. Elements differ from one another according to the number of protons in their atom's nuclei, a value called the element's atomic number, Z. Okay, so it gave us the answer right away. The way we tell elements apart is based on the number of protons in the nucleus. Okay, freeze. We were just given the answer to the questions above. So thinking back to the structure of atoms, which we read about in prior sections of this book, we know that protons are one of three essential parts of an atom, that they have a positive charge, and they are in the center or nucleus of an atom. I noticed this sentence, which is the answer to the questions above, is italicized. So let's keep that in mind as we continue reading. Also, the variable in parentheses represents an atom's atomic number in formulas. So when we see Z in regards to atomic formulas, we know that Z stands for the atomic number of an element. Okay, let's continue. That is, all atoms of a given element contain the same number of protons in their nuclei. Okay, so this line reaffirms the sentence from before. So if we have a lot of one element, let's say in a container, every atom that makes up that element will have the same number of protons in every atom, according to this section. Okay, so let's think about this more. Let's think of a tank of oxygen. Now, this tank is completely filled with pure oxygen, and every single individual atom of oxygen in this tank has the same number of protons in it as every other atom in the tank. So let's take a moment to think about that for a bit. Every atom has the same number of protons. Burn that into your brain, okay? If one of those atoms had one less or one more proton in it, it would no longer be called oxygen. According to this section, it would be a different element altogether. So that's the main idea I'm getting from this section, is the number of protons in an atom determines what element that atom is. Let's continue. All hydrogen atoms, atomic number 1, have 1 proton. All helium atoms, atomic number 2, have 2 protons. All carbon atoms, atomic number 6, have 6 protons, and so on. So yes, this sentence is just confirming my example from earlier, the idea that every atom of a certain element has the same number of protons. Okay, let's continue. In addition, every neutral atom contains a number of electrons equal to its number of protons. Okay. So we know that if an atom is neutral, it will have the same number of protons and electrons because a neutral atom means the charge is balanced. Okay, and we see that the diagram below illustrates this principle. So if we were working on a problem in class and we were given the number of electrons, but not the number of protons, we could find the atom's atomic number just based on the electrons given. And therefore we would also be able to tell what kind of element that atom is. So I'm going to stop here. Let's review the main idea. The atomic number is what defines an element. The atomic number is the number of protons in an atom. And we know that in neutral atoms, the number of protons and electrons are equal. So you could tell what element an atom is based on electrons alone. And this idea is incredibly important because it illustrates how we identify different elements. We now know that elements are differentiated not by what we can see on the outside, but by the number of protons in an atom.